Okay, the equations of circles. Right, now the equation of a circle is actually derived from the distance formula. And if you look at this diagram over here, okay, supposing we call the center of the circle HK, okay, and some point on the edge there, XY. Well, can you see the distance between those 2 points is the radius? So it is going to be X minus H, there it is, all squared, instead of X2 minus X1, and Y minus K, all squared, there it is, okay. So that's the distance formula. Now if we square both sides, we get the equation of the circle right here. Okay, there it is, with H and K being the center and R the radius. That's it. Now let's just have a look at some examples. Okay, so a center, well here we go. Suppose I've got a center at 0, 0, okay, so right at the origin, and I have, let's say, a radius of 5, okay, let's do one right at the origin. Okay, so what I would do is, what is X minus H? Again, go back to the formula. Okay, well, if H and K are 0, 0, then this is just X squared plus Y squared, because there's no H and K to put in there, equals R squared, 25. And that's it. That's the answer. Okay. Now, if we have a center at 3, 0 with a radius of 9, then can you see, okay, we don't have anything for the K. There's Y minus K, it's just Y minus 0, so it's just Y squared. But we do have an X coordinate of 3, so X, to me it looks like it's going to be 8, okay? Because X minus 3 squared plus, now think about it, Y minus 0 is just Y, okay, so squared, equals, what's 9 squared? 81. Looks like 8 to me, okay? Have a look at, say, the next one, a bit more different kind of numbers in here. Right, the center at -1, -4. So I would write X minus -1. Now think about what that will be. It's going to be +1, isn't it? Okay. I would write Y minus -4 all squared. Okay. So what I'm going to write is this. Okay, this is going to be X plus 1 all squared plus Y plus 4. Again, all squared. And what does that equal? If the radius, now here we go. If the radius is root 5, what's root 5 squared? Root 5 times root 5 is just 5. Okay, so which one's that one? Is that D? Okay, right. Okay, so let's look at the last one. That, again, sometimes you're going to get questions where you have to think, how is it given me the center? Do I have to kind of look at a good, do a good diagram? Just sketch it out, and you might be able to see, there's the radius. I can see the radius now on the diagram. Or maybe I can't see the center, but I can see it when I do it on the diagram, right? Because you need both the center and the radius to create the formula, the equation. Right. Okay, if the center is 17, 20, then straight away I have this. X minus 17, there's the H, the X coordinate of the center, squared, plus the Y is 20, so X minus 20, no double negatives in this one, all squared, equals, and you're going, whoa, what's the radius? Right, tangent to the x-axis. If you were to draw yourself, I'll just erase some of the stuff above here. If you were to draw yourself a little diagram, okay, so let's just get rid of this. Now, what I've got here is a circle with center. I'm just going to, I know it's got to touch the, there you go, ooh, touch the x-axis. If there's a center, okay, remember that's 17, 20, so that becomes these points here, okay, that's it. Now then, what is the radius of this? Well, the radius is, I know it touches the x-axis, so I put a line down here. If I just sit there, right there, okay, from here to here is the radius. Now, if you think about it, that's the y direction. What's the y-axis? What's the y-coordinate? 20, okay, so the radius must be 20, just from looking at the diagram, okay, remember, that was 20, this point here was 17, so if the radius is 20, 20 squared must be 400. Okay, which one's that? Is that C? Okay, there you go. So again, it's not always clear. You've got to look at the question. Is it giving you some information that maybe if you do a diagram, you can see what the center is or the radius. Okay, so be careful of that.